Hi, welcome to EC&M Tech Talks. Today we're going to do an electrical safety refresher. And we're going to go through items. And the way I'm going to do it is the way I work out in the field, okay? I never try and remember all this stuff that I have to do on my own out there, so I always have a cheat sheet. So we're going to use our cheat sheet today. I'm going to go through, and the first thing we're going to talk about, it says, is conduct a risk assessment. So we're going to go through and talk about the regulations, what you're required to do, what you're required to have in place, of course, why you're required to have it there. And then we're going to talk about that risk assessment. We're going to look at how to interpret a label is a very important part of that risk assessment. So we'll do a little refresher on that for you as well. The second thing we probably want to do out there in the field is once we do our risk assessment is gather up our PPE to go to work. So we're going to go through the selection of our PPE as well as our test equipment. The third topic that we're going to go over is we want to make sure that the equipment is safe to operate. So we're going to talk about verifying that equipment is suitable for normal operation. The fourth area we're going to talk about is we're going to set up our barricades, barriers, boundaries, whatever it is we need to do, whatever's in our head, we need to know what those are, understand what they are. We get the information from the label, and then we want to apply that out in the field. So we'll go through that in item number 4. And then finally, and most importantly, we want to review those steps for an electrically safe work condition, what you and I call lockout, tagout, make sure it says. So let's get going. First thing we're going to talk about is doing the risk assessment. Now it's required that we do one. And I'm not just talking about going out and saying, yeah, I better be careful out here, I could get hurt or something like that. No, we're going to use the NFPA 70E standard. That's my reference for today. Your reference is your electrical safety work program. That's what you should be taking a look at. The NFPA 70E standard says that I have to have one. And there are about 10 or more different major topics that are required to be in your electrical safety work program. Now, do I have to have that? Do I have to have a written safety program for electrical work? Yes, I do. Why? It says so as in NFPA 70E. But does OSHA say I have to have it? No, OSHA really doesn't address it. The NFPA 70E requirements are based on subpart S on Title 29 of the Code of Federal Regulations, Part 1910, Sections 332 on to 335. And what they cover, that's subpart S, and that's the way I look at it is OSHA tells us you better comply and you better be safe out there, and here's some tips and guidelines for you, regulations they call them, right? But it's not enough to tell you how to go out there and be safe. So the NFPA 70E standard was written to tell us how to comply with the OSHA requirements in subpart S. So that's why it becomes so important. If it becomes necessary, in the unlikely event you should have an incident, why OSHA, if they have to show up and they'll take a look and they can enforce the 70E standard, not in itself. It is not the law. It is referenced by OSHA, therefore they can cite it based on the general duty clause, which says that the employer has to provide you a workplace essentially free from hazards and so on, and warn you about certain things and train you and so on and so forth. And you, the employee, have responsibilities as well. So anyway, we comply with the 70E standard. We have a written electrical safety work program for our facilities. You're required to review your written electrical safety work program periodically. All the information is in 70E. Open up your 70E book to what's to be required in your electrical safe work program and compare that to your program, bounce them across one another, see if you need to make any improvements. As I say, as of this Tech Talk, we're using the 2024 NFPA 70E. So, we have to write a job safety plan. We have to have a documented job safety plan for the electrical work that we're going to do. Now, in the 70E standard, there's a good example of one, should you need one, and of course you would want to customize that for your own facility. So take a look at your electrical safety work program and see what you have. I always say it's broken up into certain logical areas. We're going to have some administrative information up at the top, who's filling this thing out, and what is the job we have to go do, and so on and so forth. Then we want to document in our job safety plan the results that we get when we go out and we look at the potential electrical hazards, or, well, the electrical hazards that we face. So in other words, what are the shock and arc flash potential? Where do I get that information? I can get that from the label. If I don't have the label, I can use something called the PPE category method. We have another tech talk that we went out in the field and actually used the PPE category method. So you can always go back and look at that tech talk if you need to know how to use the PPE category method if you do not have the arc flash warning labels on your equipment then. Now, I have to do my job safety planning. I have to identify the shock and arc flash hazards that are present. And I have to say in that job safety plan how I'm going to mitigate those hazards. Because the bottom line is, when I get to that end of that job safety plan, I want to make sure it's safe to go out and do the job. If not, I stop work and I don't do the job, do I? Until I can get it into a safe condition. So let's take a look at a label and go through and see what the minimum requirements are in the label. Now, different types of labels out there. Most facilities have labels that are specific to them, so whatever you have. But let's go ahead and put up on the screen a typical label and see what the minimum requirements are that we have on that label. It's required by the it's required by the National Electrical Code that I have an arc flash warning label on equipment. That's covered in 110.16. By the way, later on in 2025, we may well see some changes to 110.16 for arc flash labeling requirements. But nonetheless, what's in place right now, 110.16, any equipment that's likely to require servicing or maintenance after installation, and it gives us a whole list of examples, we're required to have some type of warning label on the equipment to warn people of those hazards. It has to be durable and legible and so on and so forth. So let's take a look at a typical arc flash warning label. This particular label has the minimum requirements on it that's required by the NFPA 70E standard. That's found in section 130.5H in your electrical safety work program. Wherever you address your incident energy analysis and so on and so forth, that's where you should be finding this information. So up at the top it says warning. Right, warning, arc flash hazard. Doesn't give us a lot of information. In fact, this label says warning, arc flash hazard, shock hazard. You know, sometimes we see those generic labels and they don't have anything else on them. That doesn't meet the requirements of NFPA 70E. So I have to have specific requirements. In fact, the informational note in the National Electrical Code refers us to the 70E standard as to what exactly we must have on this particular label. Now, this particular label is divided up, as most are, into two separate areas. I have an arc flash hazard and I have a shock hazard. The arc flash hazard tells me that there's a 4-foot arc flash boundary. That means if I'm going to have a arc flash over here and I'm 4 foot away, that's where the incident energy is going to drop to 1.2 calories per square centimeter, which is the onset of a second-degree burn. NFPA 70E is designed to make sure that I don't get anything worse than a second-degree burn, because a second-degree burn will heal. So I can go, if I were to go any closer than that arc flash boundary, I better have on the appropriately rated PPE in order to protect me from that arc flash. Now, it says 3.5 calories per centimeter square at a working distance of 18 inches. The working distance you'll see is typically for the equipment we troubleshoot, MCCs, control panels, disconnects, probably 18 inches. 24 inches for switchgear, 36 inches typically for medium voltage equipment. That means that the calculation is there's 3.5 calories per square centimeter at a distance of 18 inches away. So if I need to stick my head inside of that 18 inches and go down to 9 inches to read the wire label or something like that, how many calories should I protect against? And the answer is we don't know. We'd have to do the calculations. The values do go up exponentially. So if I had 3.5 calories, and I squared that, 3.5 times 3.5 comes out to be, I don't know, whatever, over 10 calories. Now that's what I would have at half that distance. So pay particular attention then to your working distance. Never go inside of that working distance. The shock hazard appears down below. Shock hazard, 480 volt AC shock hazard, nominal system voltage, right? That's the voltage off the nameplate. It calls for class 0 gloves. Class 0 gloves are rated for 500 volts AC, and so they will work on a 480 volt system. Class 0 gloves are often used. They're rated for 1,000 volts. You use whatever your facility organization requires you to use. The limited approach boundary, where's the shock boundary considered? That's the limited approach, 3 feet 6 inches. So I don't want any unqualified person, certainly, to get within 3 feet 6 inches because I don't want them to get a shock. Now, The restricted approach boundary is 1 foot away, 1 foot 0 inches, 12 inches. Okay. So what's that based upon? Anything that I'm going to take inside of that restricted area within 12 inches of those live energized parts has to be insulated. Whether it's gloves on my hands, insulated tools, test leads, whatever it is. Now, I'll mention that the unqualified person can go into the limited approach area to do, for instance, for training. They're going to be under the supervision of the qualified person in that area. There's some more details in your 70 ebook when you're training people and so forth, and people can be qualified to do one task and not others and so on and so forth. So anyway, you want to make sure you have that in your electrical safety work program. Good thing to review during the refresher. You're required to receive some basic electrical safety training based on your electrical safety work program. You're also required to have refresher training every 3 years. And the reason is this standard is updated every 3 years. So they just want to make sure that your program gets updated, your training gets updated every 3 years. Can you use this training that we're going through today as your 3-year refresher training? I don't know, take a look at what your electrical safety work procedure has to tell you, your policy. Probably not, okay? Because we don't go into enough detail, obviously, none at all for your particular facility. Can it be used as part of your refresher training? Certainly, feel free to use the video, stop it, talk about it, review your particular policies and procedures as you go through your refresher training. But every 3 years, you have to have this retraining then. So, we are required to do some type of job safety analysis. We go out, we do that, we do incident energy analysis is the best way. One of the problems that I constantly see with labeling, people will take this label and they will also put the PPE category on it. So it'll say, for instance, this particular label says I have 3.5 calories at 18 inches of working distance. 3.5 calories. Then I go over here and maybe somewhere else I put PPE category 1. That can create confusion, and that's not allowed by NFPA 70E. I'm not allowed to use both the PPE category method and the incident and energy analysis method to come up and warn people how to protect themselves out there in the field. And the reason is the confusion. Let's take an example right here. At 3.5 calories, if I were going to dress out for 3.5 calories, I would go to table 130.5G or whatever the appropriate table is that you're using in your particular procedure, and I would take a look at 130.5G, and it tells me for incident energy exposures equal to 1.2 calories up to and including 12 calories, it tells me how to dress out. Bottom line is the rating of my clothing has to be at least what the rating is for the incident energy on the label, right? Wouldn't make sense to face a 3.5 calorie arc and wear 1 calorie or just a cotton shirt or something like that. It would ignite, catch on fire. I could get 3rd-degree burns. So anyway, it goes through and it tells me I have to wear arc-rated clothing with a rating at least equal to that 3.5 calories, long sleeve shirt and pants, or an arc flash suit, arc flash face shield, and an arc-rated balaclava. So I would need my face shield from up here and my balaclava, which is my sock hood, right? Is an older term that we've used on it, but it makes sense to me. Okay? And so I put this on, and that's going to give me the protection for my, tuck it in and so forth. But that's going to give me the protection for my chin, neck, and so on. Now, it goes on, gives me my other requirements for PPE. You make sure you wear your PPE based on what your electrical safety work procedure says. If I took and I put PPE category 1 on that label, here's the confusion. To dress out for PPE category 1, I go back here a few pages to table 130.7C15C, or whatever the table is in your electrical safety work policy. And it tells me for PPE category 1, my arc-rated clothing must have a minimum calories of 4 calories. I could wear 3.5 calorie, I don't know where you would buy that, but my clothing must have a minimum rating of 4 calories. And certainly I can buy 4 calorie rated shirts and coveralls and so on. It goes on and it says arc-rated long sleeve shirt and pants, arc-rated coveralls, face shield or arc flash suit hood, arc-rated jacket, parka, and so on. It never says I have to wear a balaclava. 130.5G said I needed the balaclava. PPE Category 1 says I just need the face shield. So, boss, what do you want me to wear? You got two conflicting bits of information on your arc flash warning label. So anyway, that's one reason then why we don't use those two separate systems to try and tell, or two systems can combine them some kind of way to try and tell people how to dress out. So use either the incident energy analysis or the PPE category method. Now, once I've got my job safety plan in place, I have to do a job briefing. It's required by 7E. It's also an OSHA requirement. OSHA says that I have to do a job briefing, the person in charge. Person in charge has to be a qualified person. What are you going to review in your job briefing? Well, probably your job safety plan is the very first thing you want to go over. Of course, you'd want to review all the hazards, and OSHA as well as 7E provides the information that I cover in my job briefing. And remember, if the scope of work changes while I'm working, I have to go back, revisit my job safety plan and my job briefing as well. Next topic let's get into then is the PPE itself. And so I need to select the PPE then if I'm using that incident energy analysis method. My PPE in this case, based on that label we just saw, would have to be rated for 3.5 calories. Now, we're probably not going to have any problems with that because our everyday work clothing that we typically wear is usually rated for a minimum of 8 calories. There's an informative annex in the back of 70E that gives you some information on recommended everyday work clothing. The reason I like to wear a minimum of 8-calorie clothing for everyday work, it probably covers, 99% of the jobs that I'm going to go out there and do. In the event that I'm going to work on something over that 8 calories, then, well, I can put on an arc flash suit or whatever it is I need, whatever my policy says, and go out and protect myself at those higher incident energy levels. This particular shirt that I'm wearing is it says category 2 somewhere. Yeah, it says Cat 2 on it. Cat 2, what does that mean? Absolutely nothing. Okay? Cat 2, term, PPE category method, category 2, clothing must have a minimum mark rating of 8 calories, but that's not official. I actually look in the label on this shirt and it tells me it's rated for 8.9 calories. Oh, so I got a little bit more protection when what that label says, huh? Well, no, that's not what I'm going to go on. Let's take, I don't know, here's a pair of coveralls, for example. So I've got a pair of coveralls, and I don't know, somewhere on here it's got my their Cat 2 label on it. And so let's take a look and see. So it's good for up to, if I were using the PPE category method, okay, I might say, well, these are good for category 2. Let's see what they're rated for. Now, what I'm looking for is the ATPV rating, arc thermal performance value. These coveralls are rated for 10.6 calories per centimeter square, it says. So I've got to see that ATPV value. Now, I'm going to go through and, I should inspect my coveralls as well. It's maybe a good example. So I check my label, make sure that it meets the minimum requirements for my arc flash I could possibly encounter. And then I'm going to inspect my clothing. I'm going to use my checklist. I've got a handy little job aid that I use. My company provides it to us, and it goes through and covers all of these topics that we're talking about today, so I can keep it in my pocket because they realize I'm not smart enough to remember all this stuff. So anyway, I inspect my clothing, and when you think about that, I make light of that. But if you're out there working, what are you thinking about? Wonder why that motor didn't start. Maybe it's this, maybe it's that, maybe I need to check this, maybe I need to do that. Whatever it is, that's what's on your mind. Plus all the rest of the stuff is going on. I need to get this done so I can go over there and get this, whatever. So life is going on. Human behavior is a big factor when it comes to electrical safety. That's another good tailgate safety meeting topic for you, okay? But anyway, I go through and of course I'm going to inspect no rips, no tears, no flammable materials, no dirt, oil, grease stains, anything like that on it. And so I go through and I check out the whole garment. I make sure in this case the zipper, it's got a metal zipper, but that's covered by FR material. So I would make sure the zippers and the closures work and so on and so forth. Here's an example. Now this is another rating you may see on garments. So this is something I'd wear if it was really cold outside, right? And so I could put this on, and I could put my hard hat, my face shield over this if need be or whatever. This has a rating also. It's lined on the inside. But when I take a look at this, It's okay to wear. It doesn't have ATPV in it though. That's okay. It says EBT. And let's see, where did that go? Ah, there it is. EBT, the energy break open threshold value for this particular hood to wear over and to wear in the winter has a rating of 34 calories per centimeter square. So it's rated for 34 calories, the EBT. So I can use either the EBT or the ATPV rating. 99% of the time, I bet you're going to see the ATPV rating out there. So anyway, I select my PPE, I inspect my PPE, I make sure I've got the right PPE, I make sure it all functions properly, I try it on, whatever I need to do, okay, make sure it works okay. I look at the ratings on it. This is rated for 12 calories, it says, with the chin cup in place and so on. So, check your PPE, make sure that it is in good condition, follow your policies and procedures on that. Any questions? A good resource for you will be the manufacturer of that garment as to what any questions you might have on it. Ready? So we select our PPE. Something else we may need is, depending on what we're doing, of course, is our test equipment. So we may need a multimeter. The things that I want to do is I want to check my multimeter, turn it on, make sure I don't get the low battery on it, comes on. Physically, it's in good shape. I check the category rating on it. The more category I have, the more protection I have. Category 1 is fine for some bench work right here. Category 2, I'm just going to read the branch circuit right over here, the end of my branch circuit at the receptacle. Category 3, I'm going to go out in my plant out here and I'm going to read maybe 480 volts or whatever it is in my system. Category 4, I need to go outside and take some readings, maybe out by the service or something like that. It's all based on surge protection. The more category I have, the more surge protection I have. Okay, most of your meters, if you take a look, you've got good quality meters out there. They're probably rated, this one is rated for Cat 3, 1000 volts, Category 4, 600 volts. So I could certainly use this in my plant for working on up to my 600 volt systems indoors and outdoors. And I'm certainly not going to use it up at 1000 volts and over that. I also want to inspect my test leads. So make sure you do a good physical inspection of your test leads. Make sure they've got shrouds on the end of them. Take a look at the tips. Make sure that your test leads are rated. These are Category 3, 1000 volts, Cat 4, 600 volts. They have a double little box on them, meaning that one box inside of the other one. That tells me that they are double insulated. And then the way I like to check my test leads, I just take and I run my finger as I take a look at it and inspect it. In between my fingers, if there's anything wrong, I should feel it. And I don't repair test leads. I just cut them in half and throw them away. Okay? So I check my meter and my test leads. One thing that I want to do is, especially it's going to be required if I create an electrically safe work condition, if I'm doing lockout tagout, I want to take and set my meter up as I'm going to use it in the field to read voltage. And then I want to make sure that it works on voltage. And so to do that, we have a proving unit where I can turn the proving unit's on. I put it on either AC or DC. And then I just take and depress the test leads right here where these two little holes are, and I get a reading on my meter of 240 volts, either AC or DC, when I'm testing. So what I've done is I've verified that my meter works on voltage. Very important when we do lockout tagout, isn't it? A couple other things on PPE then. Here's some sunscreen. This sunscreen will not deteriorate the properties of my flame-resistant garment. I can buy the same when it comes to insect repellent. So consider that if you're using any of that out in the field. Test equipment. Capacitive voltage testers like this, non-contact devices, less than 1000 volts for verification of voltage, I need to use the contact instrument. Above 1000 volts, I can use my non-contact voltage detectors. Follow your procedures once again. Inspect any insulated tools. If I'm going inside that restricted approach boundary, make sure your insulated tool is rated. It's going to be, this one is double insulated, so it has the two little boxes on it. It also has a triangle, one triangle inside of the other one. That tells me it's been tested to 1000 volts. So I do a visual inspection of that as well. Now, once again, I'm moving through this pretty fast. If you need more information, well, you can watch other Tech Talks, but you want to make sure that you're covering items like this not only in your 3-year refresher, but in your weekly, monthly, whatever it is, toolbox safety talks that you have as well. Some good topics here for the electric shop folks. Now, I go through, I check my PPE. I'm going to go back and see what I've missed, right, on my little cheat sheet when it comes to my PPE. And I've inspected for cleanliness, contamination with grease, oil. I haven't checked my gloves yet. We're going to go through that. It's got the proper labels on it. No contamination, I should say, on it, okay? There's no damage that may impair the protective qualities. Proper cleaning. Follow your manufacturer's instructions. We don't use starch and bleach and fabric softeners and things like that on our PPE. Yours may well be cleaned by a third party out there. Snaps, latches, closures all work. Proper fit. If my PPE doesn't work, if this shirt were too tight, I wouldn't want to wear it. It would be uncomfortable. I want to leave it tucked in. I don't want it untucked, right? By the way, I've got all the metal and jewelry off my body. Okay, the only thing I'm wearing is my, and these are plastic frame, but they are ANSI Z80. Am I ready to go to work yet? Well, I'm going to wear my PPE based on the 130.5G, whatever's in your policy, or once again, if I'm using that PPE category method. The things that I'm going to be required in, I'm going to have to wear a hard hat, probably the face shield for arc flash protection. I need some ear canal inserts. There is a provision for ear muffs now, but I really haven't seen them used so far. And so we use our ear canal inserts. And safety glasses always under the face shields. Here's another type of face shield. This is a good one. This one is rated for 40 calories. So it's good for up to 40 calories per square centimeter of arc flash energy. And it's got the hood built into it. So when I put it on, you know, it just falls down over my chest. And what I like about it is when you're out there working, you can get pretty hot, you can't breathe, and you need to step away, get outside your arc flash boundary, limited approach, and lift that up and take a little break if you need to. Ready? Gloves on PPE. Then let's talk about gloves. First of all, I'm going to have to inspect my rubber gloves. I make sure that they have the proper the proper test dates on them. These are brand new gloves. They're still in the bag. They were tested in January 1st of this year. I put them up on the shelf, and I can keep them on the shelf until December 31st. I then issue them. I take them out of the bag, give them to somebody to go use them. They are now issued for use, and then they have to be retested then 6 months later. So that would be the end of June. So I test them in January 1st, and then issue them in the end of December. That's fine. And then I test them 6 months later, the end of June. Now I bring them in and get them tested, and they have been issued for use once, right? They were issued for use. So now they have to be retested every 6 months thereafter. So I don't get that 1 year grace period up on the shelf anymore. I have to test them every 6 months. I can wear cotton liners underneath my rubber gloves for comfort. That's a good thing. I can use things like whatever the manufacturer says for some type of powder on the inside. This is called glove dust from this manufacturer, and that's fine. I don't use things like baby powder. So that's prohibited for reasons for safety, okay? Being conductive and deteriorates rubber and so forth. So know your rubber gloves, inspect your rubber gloves, and make sure that they're good to use. Quick review then, refresher for rubber gloves. Let's take a pair of, I believe these are class zeros in here. Yep. So my class 0 on the label, it's red, which tells me that, but I don't need to memorize it. It says class 0 on it. I verify my test date, the size of my glove. I take a soft cloth tape, wrap around my hand. That's the size of my rubber glove. Now, I go through and I'm going to put the glove on my hand. I'm going to inspect it. I'm going to look it over, look for any signs of deterioration, grease, oil, anything like that. Go to the manufacturer. If you need to wash your glove and clean it, they'll tell you how to do that. And so I inspect the glove. I'm going to take it off. I'm going to pull the fingers apart. I'm going to stretch the rubber in different directions. Make sure I don't see any cracking, what we would call ozone checking then. No splits, no holes. Then on this particular glove, it's easy enough. I can turn it inside out. And I'm going to want to inspect the inside of the glove as well. I'm going to go through those same checks on the inside, and could put the glove on my opposite hand now. And once again, looking for any signs of deterioration, abnormalities. Any questions? Pull it out of service. Get it retested if you need to, whatever. Okay? So I check my rubber glove, make sure it's safe to use. I also have to do an air test on it's required. So whether I have a glove inflator, which is probably the best tool to have. And it's just a little portable inflator that I can set on my desk and use. But since I don't have one, I'm going to go ahead and trap some air on the inside, gently roll the glove up a little bit, get some air trapped. And if there's any air leaking, I'll hear it or feel it on my face. Looks like it's holding air. Make sure you do a proper and good air test on your gloves. Should be all covered in your written electrical safety procedures, something like this or whatever, then that tells you how to check those gloves out. Part of your glove safety program is what you may have in place. Okay? So we also check the protectors. We make sure that it's the proper size protector for the glove. And then we go through and make sure there's nothing on the inside of the glove that could puncture the rubber. And so this seems to be a good protector. Check both of my gloves, of course, when I store them. I put them back in the bag, gauntlet end down, because I do have little holes down here at the bottom, some grommets, that would allow my gloves to breathe, because it's probably going to have some moisture on it. For arc flash protection, I can use my rubber gloves. Take a look at your policy, the 70E standard, see what it has to say. These are leather gloves. They're rated, it says on here, ATPV 27 calories. And they call them ground gloves. But they're nice, soft leather gloves. And so they give me no shock protection. But if I don't need shock protection, they're good for up to 27 calories of arc flash protection. So whatever it is you need to wear, make sure that you wear it then. So we select the proper PPE. The next thing that we're going to do is we want to set up the barricade where we need to. On that label, it gives us the limited approach boundary, the restricted approach boundary, and then the arc flash boundary. The limited approach boundary we said is for shock protection. For 480 volts, that comes right out of the tables from whether I'm using 70E or OSHA or whatever, but right out of my tables, it's 480 volts is going to be 42 inches, right? So 42 inches, I need to keep unqualified people back 42 inches for shock protection. 12 inches, I don't want to get any closer than 12 inches unless whatever I have is insulated. That's for shock protection. The arc flash boundary is based on burn protection. And in this case, the arc flash boundary is actually a little bit further out than what the limited approach boundary is. The arc flash boundary is 4 feet or 48 inches. So what's further out? Well, 4 feet is further away than 42 inches. So I have to set a physical barricade at the furthest of those two boundaries. So whatever it is, whatever type of barricade you're using, but take and set up a physical barricade to make sure that nobody gets burned or shocked. And how do you know that? Look at your boundaries and see which one is furthest away from the live parts. That's where you set your physical barricade then. We need to verify the condition of equipment. So we go out and we check it for normal operation. There are 6 requirements to verify that equipment is safe to operate. 70E tells us that, well, the committee says that you're most likely to have an arc flash at any time you interact with the equipment. So if equipment is suitable for normal operation, then you should be able to go ahead and operate it following safe work practices. There should be no arc flash. However, you follow whatever your procedures and policies are for dressing out. 70E does not make a distinction, for instance, for throwing a disconnect switch, whether I need to wear arc flash protection. I want to make sure that the equipment's suitable for normal operation. So let's put those items up on the screen and take a look at them and talk about them just a little bit as a refresher then. The equipment is properly installed and properly maintained. 2 separate items. So installed per the NEC requirements and then maintained now per the requirements of NFPA 70B, the standard for electrical equipment. And whatever your maintenance program is, you follow that. You make sure the equipment's good, safe, installed properly, maintained properly. The equipment is rated for the available fault current. You can find that information on the nameplate, typically, or some type of nameplate data. but you want to make sure manufacturer's instructions, whatever, in the event of a fault, we want to make sure the equipment's rated to handle that fault current. Number 4 says the equipment is used in accordance with instructions included in the listing and labeling and in accordance with manufacturer's instructions. So yeah, we always follow manufacturer's instructions. That's what they designed it for, what they built it for. It met the nationally recognized testing labs such as UL or CSA. It's met those requirements, and therefore, if you use it per their instructions, it's safe to use. Number 5 is the equipment doors are closed and secured. They designed that equipment based on the doors being closed to help protect you. Now, that does not protect you from an arc flash unless it's arc-resistant equipment. So we still have to keep that in mind. Now, number 6 is all equipment covers are in place and secured. That includes all the bolts are in and so on, and proper types of bolts. And there's no evidence, it says, of impending failure. And that's sort of what I call that electrical common sense. No water dripping on the equipment, anything like that. No signs of burn marks, no smell of burnt insulation. If I meet all of those requirements, it says then the equipment's considered suitable for normal operation. If I don't meet any of those requirements, it's up to you to figure out what you're going to do. It says you're going to take additional measures as necessary. Could be anything from wearing additional PPE to maybe actually just best thing is maybe shut the equipment down to work on it, to do whatever it is you need to do. And now we're ready to go to work. So we've assembled our PPE, we set up our barricades, we've done certainly our job safety analysis, we've done our job briefing, and off we go to work then, okay? And we follow safe work practices then when we go to work. We want to make sure we don't get distracted. We want to consider human behavior. We're feeling okay. We haven't taken cold medicine or something like that. We're not feeling groggy. We're good to go to work. Our mind's on the job. And when we step under that barricade, we know, okay, whew, here it is, man. Off we go, righty? So you want to make sure that you're ready at that point, that you've got all of these other steps in place. And finally, the best thing you can do, of course, at any time is to establish an electrically safe work condition. So if I'm going to verify my equipment is in an electrically safe work condition, the first thing that I do is I determine all possible sources of supply. Walk down systems, of course, use your prints, up-to-date prints and so forth. Whatever it is you need to do, make sure you're not missing anything. Item number 2, after properly interrupting the load current, in other words, stopping the equipment, shutting the power off, open the disconnecting device for each source. I open the disconnecting device. The next step says, wherever possible, visually verify that. So if I can look at the knife blades, if I have the circuit breaker I've racked out, I can visually verify all of that. Release any stored electrical energy is the next item, and then release or block any stored mechanical energy as well, spring pressure and so on. And then apply your lockout tagout device. So whatever your procedure is for hazardous energy control, make sure you're following that, but apply your lockout tagout device. Then use an adequately rated portable test instrument. So your meter, and go through and verify the circuit de-energized. And that's where you use that 3-step method, right? And a little bit of what we talked about earlier. I go through and I use my proving unit. I could call it, in this case, I would go through and use my proving unit and make sure that my meter works. So I check a known source of voltage, make sure my meter works on voltage. Then I go in and I verify phase to phase and phase to ground that I have zero energy according to my meter. Then I go back to my known voltage source and make sure that my meter still works on voltage. And then finally, the last thing that it says in the NFPA 70E, and depending on your procedures, it says where the possibility of induced voltages or stored electrical energy exists, ground the phase conductors or circuit parts before touching them. So if needed, we don't do this a lot at low voltage, but certainly at medium voltage and above, we install personal temporary protective grounding then. So do that if you need to. So that covers a quick and dirty refresher of electrical safety requirements when we go out to work in the field. We talked about what the requirements are, why we have to follow them, what the administrative requirements are, planning, job briefings, and so forth. We took a look at some PPE, We talked about barricades and boundaries. We talked about interpreting the label. We went through normal operation of equipment, what to do if we don't meet normal operation. And then we went through our lockout, tagout procedural steps. So that's it for our electrical safety refresher for Tech Talks today. Once again, the main thing is that you do pay attention. Go ahead, make sure you've got a good electrical safety work policy in place. Make sure everybody understands it and follows it, and you'll be safe out there until the next Tech Talk. We'll see you then. Thanks.